Hello everyone, welcome to week 7 of the MyMathLab work. Question number 5 is one that I chose, and this one is pretty straightforward. The derivative of e to the x is just e to the x. So the 3 can stay there, so my answer in this little box would be that 3 stays there, the derivative of e to the x is e to the x. Next up, the derivative of this little the derivative of this little x right here is 1, so that means it's 4 times 1, also known as 4. And then the derivative of the natural log of x. So that is just 1 over x. And the minus 5 can just stay there. And this one cannot be simplified, so we're already done with that one. Next up, I randomly chose, not randomly, but anyway, I chose number 7. So find the derivative with respect to x. So it's just saying that x is the variable. And what I could do is take this 11, before taking the derivative, I can take the 11 and put it in front and multiply. So that's one of the rules from logarithms, this one right here. You can take the exponent, put it in front, and multiply. And then when you take the derivative, the constant 11 will just sit there and wait while I take the derivative of natural log, and that would be 1 over x. And then most likely, right here, they want you to simplify your answer. So that would be 11 times 1 on the top, so it turns out that it's just 11 over x. That one's done. And proceeding down the line, next is number 9. So the reason I chose this one is because of this guy right here. So if you have something like x to the 19th power, when you take the derivative, that would be 19 x to the, subtract 1 from the exponent, so it looks like this. And it's true no matter what number this is. Well, in this one, they happen to put the number e. So that means that when you take the derivative, you would take the e, bring it in front, and multiply with the 2. And then you would subtract 1 from the exponent. So that's just going to be e minus 1. Then it goes over here, minus 7. And then the derivative of e to the x is just e to the x. And then this one is done. Type an exact answer in terms of e. So they're saying don't put a decimal or anything right here. Just type it exactly as it is, just like that. And then deserves a check mark. Or even a happy face. That's an even happier face. All right. Number 10. Why did I choose this one? Oh, find the equation of the tangent line. So in here, they tell us what x is, but they don't tell us what y is. So we do need to find out what y equals. So if, before you take the derivative, you plug in a 1 for x right here, it's going to say 1 minus 8, and then natural log of 1. I happen to know that the natural log of 1 is 0, which means this is going to be 8 times 0, which means it just leaves this 1. Let me see if the calculator agrees. So 1 minus 8 ln of 1 equals 1, 1. Okay, then we need to do the derivative. So the derivative. Well, the derivative of 1 is 0, so that's gone. The negative 8 will just stay there while I take the derivative of natural log, which is 1 over x. And then take this 1 and substitute it for x. That means it's going to be negative 8 times 1 over 1. That equals negative 8, and the derivative tells you the slope. So now we have what x equals, we have what y equals, and we have the slope, which is everything we need to find the equation of the line. So then it would go y minus the y value of 1 equals the slope times x minus the x value of 1. And then I just need to simplify this and I'm done. It's a beautiful time for the red pen. So this is going to be negative 8x, and this is actually going to be positive 8. So I have negative 8x plus an 8 on the right side. And what's the last step? To solve for y, the last thing I need to do is add 1 to both sides. So add 1, uno más, which I always thought was a great name for a Mexican food restaurant. Uno más. And there we go. There's the equation of the line. And notice in here, they already put the y equals, so don't put the y equals a second time. Just put whatever you get for your answer right there. And, okay, so this one takes a little more time. Just to go slow and make sure I understand what they're asking. A student claims the tangent line for this at this passes through 0, 0. Is she correct? And then they put a graph, although I don't trust this graph completely because I don't know if they're trying to trick me or not. So basically I'm just going to do the work that I just did. So they gave me what x equals, they gave me the function, so then I could plug that in and go, that means y equals e to the 1, which is just the number e. And then I could find the equation of the line. Oh, sorry, I still need to do the derivative. So this is just the y part. Then the derivative of e to the x is just e to the x. That means when you plug in a 1, it also equals e. It's e to the 1. And then do the point slope formula. So y minus the y value, which is e, equals the slope, which was e, times x minus the x value, which is 1. So that's the equation of the line. And she claims that it's going to pass through 0, 0. So in other words, if x equals 0, y equals 0. So if you plug in 0 for y, and you plug in 0 for x, is it actually going to be true? Well, on this side, that's negative e. And on the right side, this is a negative 1 times e is negative e. And this is true. So the student is, are they correct that it's going to pass through 0, 0? So then my answer is yes, it does pass through that point. And then they just ask you to redo the same work with x equals 2, but it's the same work except instead of x equals 2, it's x equals 1. And that was number 12. Next up, number 17. Use a graphing utility. So they're basically saying you could use a graphing calculator or Desmos and find the points of intersection. Oh, so I actually did this in the lecture part, but let me just go over it real quick. So you graph the two functions. So one of them is just 6 natural log of x. And make sure you're using this ln, not the log. 6 ln of x. And then also, so the first one's going to be blue and the second one's going to be red, on my calculator anyway, x raised to the 1/2. And then zoom standard, so zoom number 6. And then I should be able to see the two graphs are crossing right there. So the next thing to do is go to second calculate, find out where they intersect, and then you just move the cursor until it's close. And for some reason you have to hit enter 3 times, saying that's my guess. Yes, that's still my guess. Yes, that's still my guess. And finally it says the intersection is when x equals a 1.2. So, oh, I almost missed this one. Type it as an ordered pair. I was only going to write down the x, but they want the x and the y. So let me see, the calculator says that the x is a 1.2 and the y is a 1.096. So use a comma. Okay, I did that. Round to the nearest hundredth. So that means 2 decimals. So I need to round this to 2 decimals. So the 6 is big enough that it's going to round the 9 up to a 10. So this one gets rounded to 1.10 once you do the rounding. And the first one was fine. And the comma in between. All right, what's after number 17? Obviously, it's number 19. And I chose this one because when I looked at this, I thought, oh, wow, this is a hard, oh, wait, no, it's actually not. So that's the reason that I'm doing it. So find A, the derivative of two things. Because I was thinking when I saw this problem, I thought, okay, you have to use the quotient rule. But they gave us such nice simple functions that the t function divided by the b function is, so the t function is just x to the 8. The b function is x to the 4. And because those are so nice and simple, I could just simplify. And that means I just subtract the exponents, which means that it's going to be x to the 4. And then they said without using the quotient rule. So that means now you can take the derivative, and so that's 4x cubed. There's the derivative. Part B, what's the derivative of t divided by the derivative of b? So now they're saying take the derivative of each one. So for t it would be 8x to the 7. And for b, it would be 4x cubed. So I took the derivative of each one and then divide them. So the derivative of t divided by the derivative of b equals, so for this one, I got an 8x to the 7. And for this one, I got 4x cubed. And then when you reduce, an 8 divided by 4 is 2, and then subtract the exponent, so 7 minus 3, that's going to be x to the 4th. And their point with this one is that when you divide them, that's different than dividing their derivatives. And also, if you have a quotient, if you can reduce it, that's best to reduce it rather than doing the quotient rule. But their point here is that if you take the derivative of each one separately and then divide them, it looks nothing like this. Note that the answer is different. So anyway, that was their point. And number 20. Find the derivative and simplify. So in here, because they have a plus in between, they use the product rule. And the product rule has to have a plus in between, so I know C is not the answer. And for the product rule, you have to take the derivative of this, so that's going to be 12, because 4 times 3, 12x cubed, and then leave the x cubed minus 3 alone, plus 3x to the 4th gets left alone, and then take the derivative of this, which is going to be 3x squared. And then the only thing is they might switch the order. So 3x to the 4th and 3x squared. So this one's good so far. They put the 12x cubed in the back, but that's still the same thing, and that's the same thing. The answer is A. And then with this one, they switched. This is supposed to go with the 3x squared, and then they switched it. So that's wrong. And this one, they put a minus. The product rule does not have a minus. So I'm definitely confident that the answer is A. A little spiky here. And then the last one that I want to do is number 32. Find the derivative of this. Okay, so that means use the quotient rule. So for the derivative, the quotient rule goes, the answer is going to be a big fraction, and the bottom needs to be squared. Then for the top, you start by taking the derivative of this. Since I don't know what the f of x is, when I take its derivative, I just have to say the derivative of f goes right here. And then leave x to the 14 alone. For the quotient rule, it's got minus. And then you leave the f function alone and take the derivative of this, which is going to be 14 and then x to the 13. So this, when you raise a power to a power, you multiply. So this on the bottom is x to the 28. So it has to have x to the 28. So this one, no. This one, no. It can be this one, or it could be this one, because both of those have x to the 28 on bottom. And then this one has the minus, and this one has the minus. And, oh, hold on, Greg. Let me uncross these out because I see that they simplified their answer and I did not. Well, that's why we're doing this. Okay, so like I said, this is x to the 28. And then what they did is they simplified and they said, well, this has 13 x's, and this has at least 13 x's, and this has at least 13 x's. So we can cancel off 13 x's. So those will be gone. If you subtract off 13 x's from this, it's going to leave x to the, let's see, 28 minus 13, that's 15. And then subtract off 13 x's, which means that it's basically just a single x. Now I see I should not have crossed off a, because x to the 15 is on bottom. Right here is 14 times f of x, that's it. And this has the x times the f of prime x right here. So actually, it was a. And then I have to give it to him. That was a good one. You almost tricked me. But I forgot to reduce. Once I did, then it's a good one.